This is lesson 1.5, equations. Your objectives are to solve equations with one variable and solve equations with two variables. Solve equations. A mathematical sentence with one or more variables is called an open sentence. Open sentences are solved by finding replacements for the variables that result in true sentences. The set of numbers from which replacements for a variable may be chosen is called the replacement set. The set of all replacements for the variable that result in true statements is called the solution set for the variable. A sentence that contains an equal sign is called an equation. Example 1. Find the solution set of 3a plus 12 equals 39 if the replacement set is 6, 7, 8, 9, and 10. So look what they did. They took the equation and they wrote it with a question mark over the equal sign using each of those 5 values from the replacement set. Then they test each one and see which one, if any, comes out to a true statement. The one that was true is when a is 9, because 39 equals 39. So the solution set is 9. So just substitute each value from the replacement set into the equation to see which one is true. Example 2. Solve the equation. Notice b is already by itself. We just need to work out the other side of the equation. You can use the order of operations to help you. You can do the parentheses on top and bottom. 3 plus 1 is 4, and 7 minus 4 is 3. Then you can do the multiplication. 2 times 4 on the top is 8. The denominator, 3 times 3 is 9. So b equals 8/9. Find the solution of each equation using the replacement sets for x and y. Number 1, x plus half equals 5 halves. So we'll substitute all the values of the replacement set. The first choice is 1/4. 1/4 plus half, does it equal 5 halves? Notice the question mark over the equal sign. 3/4 equals 5 halves? No. 1/4 plus a half is 3/4, not 5 halves. That's false. Next, test a half. Does a half plus a half equal 5 halves? No. A half plus a half is 1. That one's false. The next choice is 1. Does 1 plus a half equal 5 halves? No. 1 plus a half is 3 halves. That's false. Does 2 plus a half equal 5 halves? Yes, it does. 5 halves equals 5 halves. That's true. Now, there might be more than one solution, so check the others as well. Does 3 plus a half equal 5 halves? No. 3 plus a half is 7 halves. So the only one that was a solution was 2. Number 3, y minus 2 equals 6. Now let's use the y replacement set, which is 2, 4, 6, and 8. Does 2 minus 2 equal 6? No. Does 4 minus 2 equal 6? No. Does 6 minus 2 equal 6? No. Try 8. Does 8 minus 2 equal 6? Yes, it does. That's the true one. So y equals 8. Substitute each value from the replacement set in and see which one gives you the true statement. Number 5, y squared minus 2 equals 34. Use the y replacement set. Test 2. Does 2 squared minus 2 equal 34? No, it does not. Does 4 squared minus 2 equal 34? No, it does not. What about 6 squared minus 2 equals 34? Yes, that one's true. Test 8. Does 8 squared minus 2 equal 34? No, it does not. So the only true one is 6. So y equals 6. Notice in these questions, you put the answer in brackets. Number 7. 2 times the quantity x plus 3 equals 7. This time we will use the x replacement set, starting with 1/4. Is that equal? No, it's not. 6½ does not equal 7. What about when x is half? 2 times 1/2 plus 3 equals 7? Yes, it does. That one's true. What about when x is 1? 8 does not equal 7. That's false. When x is 2? 10 does not equal 7. That's false. Or when x is 3? 12 doesn't equal 7, so that's false. The only true one was 1/2, so x equals 1/2. For number 9, y squared plus y equals 20. Use the y replacement set, which is 2, 4, 6, and 8. Does 2 squared plus 2 equal 20? No, it does not. Does 4 squared plus 4 equal 20? Yes, it does. That one's true. Does 6 squared plus 6 equal 20? No, it does not. Does 8 squared plus 8 equal 20? No. The true one was 4, so y equals 4. Substitute each value from the replacement set in and see if it's a true statement. Solve each equation. A equals 2 cubed minus 1. Do the order of operations. Do the exponent first. 2 cubed is 8. And 8 minus 1 is 7. Make sure that each line is the equation written. It has the variable, the equal sign, and whatever it equals. Good organization. For number 11, n equals 6 squared minus 4 squared. Do the exponents first. 6 squared is 36. Do the other exponent. 4 squared is 16. And 36 minus 16 is 20. Notice, it is an equation on each line. Everything stays organized. For number 12, w equals 6 squared times 3 squared. Do the exponents first. 6 squared is 36. Then do the other exponent. 3 squared is 9. And then do the multiplication. 36 times 9 is 324. So w equals 324. 13. A fourth plus 5/8 equals k. To add these fractions, I need a common denominator. Using 4 and 8, the common denominator is 8. 4 times 2 is 8, so let's multiply the first fraction by 2 over 2, giving you 2/8 plus 5/8 equals k, and 2/8 plus 5/8 is 7/8. It is okay to have the variable on the right side of the equation. Number 14, 18 minus 3 over 2 plus 3 equals p. I've got a fraction bar, so let's work this fraction separate with the numerator and the denominator. 18 minus 3 is 15. On the denominator, 2 plus 3 is 5. And 15 divided by 5 is 3. 3 equals p. Number 15, t equals 15 minus 6 over 27 minus 24. We have a fraction. Do the numerator and the denominator separately. 15 minus 6 is 9. On the denominator, 27 minus 24 is 3. 9 divided by 3 is 3. How do you know when you're finished? when you have one number left. Number 16, 18.4 minus 3.2 equals m. There's only one thing to do. Do the subtraction. You get 15.2. Number 17, k equals 9.8 plus 5.7. There's only one thing to do. Add. The answer is 15.5. Decimals are fine. Fractions are fine. Just make sure everything is reduced and simplified. Number 18, c equals 3.5 plus 2 1/4. You need a common denominator. With 2 and 4, the denominator is 4. 2 times 2 equals 4. So 3 1/2 becomes 3 2/4. Now add. Add the whole numbers. 3 plus 2 is 5. And 2/4 plus 1/4 is 3/4. 5 3/4. Solving equations with two variables. For these we will have story problems that have different numbers. Pay attention to the numbers. The number that occurs one time in the story is the number that's by itself in the equation. The number that occurs over and over again and repeats will be a number that's times a variable in the equation. And the total will be the variable that's by itself. So the basic formula we will use will have the total, which is a variable, equals the repeated number times the repeated variable plus the number that occurs once. In this example, Emily belongs to an internet music service that charges $5.99 per month and 89 cents per song. Write and solve an equation to find the total amount Emily spends if she downloads 10 songs this month. So we have some numbers here. The number that occurs once for the month is the $5.99. She's charged that one time. The number that occurs repeatedly is 89 cents. That happens every time she does a new song. The total is the total cost. So that gives us the equation C equals 0.89n plus $5.99. And n is the number of songs per month. If she has 10 songs, substitute 10 for n. And see what that becomes. When you work that out, the total cost is $14.89. Make sure all of the parts go in the correct place in the formula. Question 1. Auto repair. A mechanic repairs Mr. Estes's car. The amount for parts is $48 and the rate for the mechanic is $40 per hour. Write and solve an equation to find the total cost of repairs to Mr. Estes's car if the mechanic works for 1.5 hours. Well, let's look at the numbers and see which ones occur once and which ones repeat. The number that occurs once is the $48 because he only gets the parts one time. The repeated number is the $40 per hour. It's $40 every time an hour goes by. And the total, we can use a variable like C. So the total equals the repeated number times the repeated variable, which could be h for hours, plus the number that occurs one time, which is 48. There's your equation. So what's the total cost if the mechanic works for 1.5 hours? Well, substitute 1.5 for h. And that gives you a total of $108. So remember, the $48 happened once because you only get the parts one time. The repeated number was 40 because it's $40 every hour. put the numbers in the correct place in the formula, and work it out. Mr. Moore purchases an inflatable kayak weighing 30 pounds from an online company. The standard rate to ship his purchase is $2.99 plus 85 cents per pound. Write and solve an equation to find the total amount Mr. Moore will pay to have the kayak shipped to his home. Which number occurs once? That's the $2.99. Which number occurs repeatedly? That's the 85 cents. Every pound is another 85 cents. The total, pick a variable, we can use t for total. So our equation, the total, is the repeated number times the repeated variable, we can use p for pounds, plus the number that occurs once, that's $2.99. So how much will it cost to ship it when it weighs 30 pounds? Well, substitute 30 where the p is. And that's a grand total of $28.49. The speed of sound is 1,088 feet per second at sea level at 32 degrees Fahrenheit. Write and solve an equation to find the distance sound travels in 8 seconds under these conditions. Which number occurs once? Well, there's not one. Don't say it's 32. 32 is a temperature, which isn't having to do with our sound and the distance traveled. Which number occurs repeatedly? Well, that's 1,088, because every second you go another 1,088 feet. The total, you can use d for distance. So the total, d, equals the number that repeats, 1,088, times the repeating variable, which is s for seconds, plus nothing. So we don't need the plus 0 at the end, so our equation is just d equals 1,088s. Notice that we're not using the 32. Don't think you have to use every single number. Make it make sense within the context of the question. Now, how far does sound travel in 8 seconds? Well, seconds is s, so substitute 8 for s. And that gives you 8,704 feet. Your town decides to build a volleyball court. If the court is approximately 40 by 70 feet and its surface is of sand 1 foot deep, the court will require about 166 tons of sand. A local sand pit sells sand for $11 per ton with a delivery charge of $3 per ton. Write and solve an equation to find the total cost of sand for this court. So I'm looking for the total cost, so my numbers will have to do with money. Which money number occurs once? And there's not one. Which number repeats? Well, there's $11 per ton for the sand and $3 per ton for the delivery. So 2 numbers repeat. The total can be C for cost. So C for the cost equals the repeated 11 times the number of tons plus the repeated 3 times the number of tons plus 0, which is the 0 value that occurred once. So our final equation, put those together. 11t plus 3t is 14t. That's our equation. What's the total cost? Well, there's 166 tons, so substitute 166 for t. And that gives you a total cost of $2,324. So make sure you're putting the correct numbers in the correct place. The number that occurs once is by itself, and the repeating number is multiplied by the variable. Those numbers must be the same type of number that the total is. If the total is cost, those numbers have to be money. If the total is distance, those numbers should be feet or miles or something like that. For single variable equations, make sure that you use the replacement set, test each value, and the one that is true, that's your solution. If you're given an equation where the variable equals something, use the order of operations to work that out. And once it's in simplest form, that's your answer.